Next up, we're going to have Adam Compton from Rapid7, who's going to tell you how to script yourself out of a job.
Yeah, pretty much.
Dashing and daring, courageous and caring, faithful and friendly with stories to share. All the
Not yet. No questions yet. Not from you at least.
Marching along as their song fills the air.
All right. Ask me later. So yes, my name is Adam Compton. I'm from Rapid7. I am a senior security consultant there. Today's presentation is going to be on automated pen testing toolkit, scripting your standard activities during a pen test, things of that nature. Co-presenter, co-author is Austin Lane from Rapid7 as well. He's in Texas at the moment and not here, so he's not invisible or something, so don't worry about that. So, one slide on who am I. Adam in 5 words. I don't like the big slides, but yeah. So, my family, my children. I've been doing pen testing and programming for a good number of years. And as such, as with anything that you do a long time, you tend to get frustrated with repeating the same processes over and over and over again. Thus, the decision to make this tool in this presentation. Well, we're going to go ahead and start out, give a little background here. Most pen testing often follows the exact same basic framework, basic process. You start out with some sort of recon, and you do some simple testing, test some creds, things of that nature, and eventually you're hopefully going to exploit a system, get on, dump some other information, upload a different shell, whatever, and then you're going to get to something interesting. You're going to pivot, keep moving on through the network. A lot of this is very common, and you're going to do the same things network to network, whether it's going to be running NMAP, whether it's going to be running responder, something like that. You're going to follow the same process throughout. And yeah, there's going to be the outliers, things that are unique to a particular customer or unique to a particular network. But this tool isn't going to, or this talk and tool isn't going to be focused on those outliers. It's more on the commonality among all vulnerabilities, penetration testing. That same routine that we just talked about, like I said, it's very repetitive, and it does tend to be slow on very large networks. I'm talking not like your one class C or 2 class C networks. I'm talking when the customer gives you a class B and says, here's 65,000 possible IPs. Go and have fun and hack it. And you're like, wow, that's going to take a while to go through all of that, especially for what some people call the low-hanging fruit or the common things that you're going to find on most networks. You're really wanting something to help you out with that. So what can you do? You can automate it. A lot of that repetitive part can be automated. There are some solutions out there already they say they automated. In fact, if you look at it, it's just a shell script of running one command after the other. I guess in a fashion, you can consider that an automation. From my point of view, that's not really the type of automation I was looking for. Thus, continued on. So we wrote a tool to help with that. And it's APT2. I know the ASCII art looks a little odd there, but keeping with my tradition of naming new products and tools after acronyms that already exist, I went with APT on this one. It's Automated Penetration Testing Toolkit, so APTTT. So I think that's right. One too many T's in there, but yeah, you get the point. So going back, your standard, why can this be automated? Because it's repetitive, routine. You usually start out with running NMAP, finding some open ports, finding interesting systems, services. You start reviewing those ports, looking for anything nice. Oh, we found port 21. Does it have anonymous FTP? Oh, found port 445. Is there anything I can do with there? Open shares. Does it have MSO 8067? Something of that nature. You're going to go through each one of these, looking at it, trying to figure out what can you do next, what's going to be the next juicy thing that's going to get you further down into penetration testing. Yeah, at some point, you might get pull out some better tools like Responder, Metasploit, crack map exec, something like that to help get you a little further into the network, maybe get you some creds or some DA accounts, something like that. And eventually, you're going to take over the domain controller, the database, whatever the target was for that penetration test. It's not always going to be, can you get domain admin? It's going to be sometimes, can you get access to this one piece of data or this one table in this one database? They don't really care about the rest. Oh yeah, it's a great finding if you can get those stuff, but you're going after your target. But yes, the Homer Simpson happy dance. Couldn't find an animated one. I really tried to find an animated one. I could not find it. So the question is, we've been doing this for a long time with the same process over and over. And if it's not broken, then why am I trying to fix it? Well, mostly for a few reasons that I've encountered over the years. One is repeatability. If I run an engagement the penetration test this month and 6 months later the customer asks for it again, whether it's me or somebody else on the team who's doing that same penetration test, we might do it in a different order. We might use some other tools, which is fine. But the problem is if we forget to run a tool or a particular attack technique that the previous person did or what have you, then the customer starts to question, well, why didn't you find it this time? Or why did this other person do it this way? It's that repeatability. You want to be able to reproduce the same sort of test time after time. Consistency follows along with that. If two people on your team perform the same assessment, you should find relatively the same findings, at least for the more common ones. Yeah, somebody might be really good at reverse engineering, somebody might be really good at knowing network architecture, and they're going to focus on some of those areas, of course, but the commonality in there should be the same. Because it can, as I said before, it can be very tedious and slow. You're going to be trudging through. If you have 5 days to do a large network, you're probably going to be late on Wednesday, early on Thursday before you actually get to do anything interesting because you're still going through all the mundane stuff that you're doing on every engagement. And manually parsing through all the data is prone to human error, as I know well myself. You're going through, you tab through an output too fast, you're not looking at it, you have your regex wrong, something, and you just happen to miss one of the findings. Thus, you tell the customer, hey, you're fine. And then later you just happen to go back and look at the data and you're like, oh no, they weren't because they had this issue and I didn't report on it. But okay, I could have done all X, Y, and Z. It's to help you get through that without missing as many issues potentially. And again, automation can help with all of these steps to standardize, to repeatability. And I just realized that's probably misspelled, but still. Let's move on before people focus on that. So why not use your favorite scanner of choice up here? Whether it is, I was going to say Nexpose, but I've heard that other one too once or twice. I don't know where, but yeah, still. But still, it doesn't matter which product you're talking about. There are plenty to choose from, whether it's on the web application front, whether it's on network in general, if it's on mobile devices, there's lots of different tools, frameworks out there to use already. And there again, they can be very useful and very powerful in specific circumstances. Being from Rapid 7, I've run Nexpose on a large number of targets. And on some of them, the way the network is architected and all that, I'm spending more time trying to fix certain little issues to get it to scan right than to do the testing. Or I might be doing a mobile app and Nexpose doesn't target mobile apps, something like that. There might be other things out there. But yeah, they're very useful in certain scenarios, but they're not a general solution in a way. And I'm sure my employer is going to yell at me for saying that. But still, some are open source, or some are cheap, some are not. So, but yeah, so there's plenty to choose from. They can be very useful, and some are cheap or open source. Great things to all have in your tools. However, some of them can be fairly resource intensive. If you're going to deploy a small box onto a network, say you're not going to be on the network, you're shipping them a box, something like that, or a VM or something like that. Some of these tools require fairly intense resources to be able to run properly, which might not always be available to you. Go back. Some of them can be fairly expensive, tens, 20s, 30s of thousands of dollars. And even when they are open source, how easy is it really to add a new tool to the repertoire, to add a new check to it, some of them can be fairly easy, but not all of them. Most of them are going to be closed source, and it's going to be really hard to get the check added in. It's going to go through. You have to contact the vendor to get everything added in, all that. So that is why I wouldn't always say that your favorite scanner is always going to be the best choice. Yes, don't get me wrong. Use it. Please use your favorite scanners. They do work well, but don't just rely on those because they're not always going to be the best solution. So if you're going to automate some of this, what's going to be the way I would recommend doing it? Automate it with scripting. Whether it is in Bash, Python, do it through Metasploit's RPC library to automate some of the stuff, whatever the case is. I chose to write the tool in Python, but it uses everything else in the process as well. And this time I ended up using Kali as the base VM. You can run this on any, well, when I get into it, I'll describe more, but it doesn't really matter which Linux-based OS you run it on. Yes, it requires Linux, but I've been building it on Kali because most of the tools and scripts I typically use already are there, so I can leverage that. And I think most pen testers tend to use Kali anyway. And if you don't, it will still work on there. You might just need a couple of tools added in or what have you as you need to progress through it. So go ahead and start talking about the tool in more formal fashion. APT is designed to automate, as I said, the common stuff, the manual stuff, the repetitive stuff, the standard stuff. It is a framework toolkit. It is a tool that has modules, and you can write those modules and add to it. So sure, it's a framework. It's a buzzword. I threw it in there. It is consisting of primarily an event queue that tells each module when to execute and how to execute. It has a series of modules that do each of the checks or calls out to each of the different tools that can do the checks, and a knowledge base to store all the data. There's two knowledge bases technically. One that is a actual knowledge base, and one is just the flat files that you can look at. I'll show that later as well during the demo. How does it work? First, you either give it an IP range to start scanning itself, which it uses NMAP to do, or you can run NMAP and feed the output into the tool, and it will progress from there. As I'll talk about later, I want to add additional inputs to it, whether it be Nessus, Nexpose, Burp, whatever the tool of your choice. I want to add additional inputs so you can feed those outputs directly in and let it take off running. Stop. So what does it do? Once it reads in the NMAP file where it runs NMAP itself, based on the ports it finds, on the services it finds, it starts building up an event queue. Every port it finds, it fires an event saying, hey, there's a port 21 is identified. If it finds a new host, it says, hey, new host 1.2.3.4 was found. So forth, a new service, new web service was found. It adds this all to a queue. Then it goes through that queue, looping off, popping them off, and saying, hey, is there any modules listening for this event? And if one answers yes, for example, new port 21, the anonymous FTP module might listen for that and say, hey, I'm listening for port 21. So it'll take that and start running and doing its check. Can it authenticate? Can it validate that it's anonymous FTP? If yes, then it itself will fire an event out saying, hey, found valid anonymous FTP. This FTP server has creds of blank, blank, what have you. Then there might be another module later that's listening for valid creds for FTP, which will log into that server with those creds and then do file share searching for interesting files, which is in there. I mean, this is how it chains together. You're not scripting it out saying, I want to run this tool, then this tool, then this tool. It's all event-driven, where depending on which events are encountered, which services are found, it makes its own decision as it's going through as to which modules need to be run and when. As I was saying, modules can create their own new events based on what they found, what kind of data they gather. For example, as I was saying, the anonymous FTP module, if it couldn't log in anonymously, it wouldn't fire a new event saying anonymous FTP. It would just say thank you and close out and let a next module run. But if it did find anonymous FTP, it would fire that event. which, as I said, something else may be listening for. And this process keeps looping and looping until there's no more events in the event queue and the program terminates. One thing to say, every time one of these modules runs, its output of whatever command or process it is running is logged into a proofs directory. So you can look at the actual output of it if there's additional information you want to scrape out of it or pull out or look at for whatever reason. And that'll be demonstrated in the demo in a moment. So how does this help? Well, one, I've also added multi-threading to it, and I hope it's thread safe, but so far it appears to be thread safe. I think I've added all the checks in. But it is thread safe, I believe. It is multi-threaded. You can set how many threads you want each module, how many modules at a time to be running. I think the default is either 10 or 20, and it'll process through a large network fairly quickly with that. New modules are fairly easy to create. I don't know if I'll have time to go over that here in this presentation. If not, it's all going to be on the wiki, on the how-to, all that. And I can, if you talk to me later, I can probably share out some videos on it as well. It basically consists of taking the template module, changing out some of the description at the top, and then putting in the command you want to run. Then it's up to you how you want to parse that output to do additional features, such as reading out user list or something. But that is going to be the meat of the module. It's fairly straightforward, fairly easy. Right now, to get it to running, it is fairly easy to go. You just grab yourself a copy of Kali or Linux distro of your choice. You clone the repo, and it's good to go. You might ask, well, I might not have all the required commands or tools installed. That's fine. Each module has a list of the required commands that it needs to run. And if those commands aren't available in the system, it outputs a command output saying, sorry, I cannot run because this tool is not here. Then it just moves on to the next module and continues on. It's fairly fault tolerant in that way. But to get full functionality, you'll want to look for those kind of outputs and then add those tools into your distro of choice so that you can have full functionality. Oh yeah, that's what I said. And of course, if it doesn't have a module for your favorite tool, it's easy to create them. Make one, do a pull request. It'll get added into the main body of the tool later on. And you can use it on your own up until then anyway. So what can it do? Like I said before, it starts out, it identifies services, operating systems, ports, things of that nature. Any web app, X11, anything GUI, it tries to screenshot so that you can take a look at it later. It looks for FTP and other file shares. If it can authenticate to them, whether anonymously or not, it'll connect to them, search for. That part is partially working, but it'll search for interesting files based on regex, things of that nature. If it finds any, it downloads them. It can brute force certain accounts. Based on what modules have been created in the tool, it will run the appropriate Metasploit module, capture the output of it, keep the sessions alive, things of that nature. It doesn't rely on Metasploit, but if you have Metasploit on your system, it will definitely make use of it if you have it there. It can compile a list of hashes, throw those into John the Ripper or Hashcat, crack them, store that back into the knowledge base for other modules to make use of down the road. And in general, if you happen to look in the user share directory or user bin or any of the, basically anything that's command line, you can make a module out of. And hopefully, most of the auxiliary and the exploit commands in Metasploit, most of your standard tools will be incorporated into APT2 at some point. Right now, there's about 30 some odd modules in there. That gives you a good basis to build off of. This is a fairly early release of it, so please be patient. It will get better as time goes on. Here, anatomy of a module. I promise, demo is coming here fairly soon. They all inherit from an extender-based module, so it helps with extending it and whatnot. And they all have a name, a description, what tools are needed for it to be run, what events is it listening for, its safety level. I'll come right back to it. And process. Process is the function that does the stuff, if you want to say it that way, for each module. It's the one that executes the command. It's the one that calls out to Metasploit to run some module. It's the one that tries brute forcing passwords. It's the one that does whatever. That's the one that you're going to spend most of your time in. Safety level is on a scale of 1 to 5. It defaults to 4 or 5. I need to check again, which means that it shouldn't do anything bad to a network. It's going to try stuff that is very kid glove. It's not going to brute force accounts. It's not going to do anything like that. When you get down to safe level 1 or 2, you might lock out accounts. You might do things of that nature. And when you run the tool, you can specify what's the minimum safety level you want to run at. So if you're saying run it up and down to safety level 3, and there's a safety level 2 module, that module won't be run. So most of your information gathering and things of that nature are all going to be in the level 5, whereas things that might blue screen systems or easily lock out accounts are going to be 1 or 2, things of that nature. And it's just a way for you to have some confidence in what kind of attacks are going to be done to the systems. Are there limitations to it? Yes, with any tool and any implementation, there's going to be limitations. First, the tools that you include or modules you write need to be non-interactive. If you can find a way to script them so they are not interactive, great. Anything that requires a GUI, probably not going to be a good choice to write as a tool here. Find a different way to do it. It's just for the sheer nature that this is an automated process, which by definition means you're not interacting with it. So next, multi-threading can be difficult, can be tricky because there's lots of traffic, and some modules happen to have some conditions that you don't want to run multiple of them at the same time, such as responder. If responder is kicked off, you don't want to run another instance of responder on the same network. Bad things may happen. It may error out. It may give you false results, things of that nature. And the limits can be defined in each module if you so choose. And brute force with caution, you may break things. That's why use safety levels. If you're not concerned with locking out accounts, breaking things, sure, go ahead. Fire it with safety level 1 and have fun with it. Otherwise, stick to 4 and above, maybe 3 and above. It's all depending on what kind of network you're looking at and how risky you want to be. And at the moment, I haven't addressed this, but I hope to at some point. Non-standard ports and service names can throw off the modules. For example, if you're running let's say a common one, Telnet, but not, let's say you're running it on port 2000 for some reason. The module isn't going to detect it based on the port. It may on the service name, may not. So things that are heavily non-standard or SSH on port 22,000 or something like that is going to throw it off. Or when things are common and standard, thus the standard automation process of it work well. This I'm hoping to address in the next couple of weeks, month, to try to add more logic in there to help account for that. But at the moment, that is a limitation. Now for the demo, if I can get this to work. Let's see. Come on. Not this time because I'm doing a recorded one. I cheat. All right, whoa, stop, go back. All right, let's get started with this. Move that over just a little bit so people can see. Yeah, that's good enough. All right, so when you do a clone or get clone of this, you're going to find a directory that looks like that. You're going to have a few common things in there. First, the primary script is apt.python. You're going to have demo.xml, which is the, go ahead and pause that so I can talk about it just a little bit. Hey, go back. I didn't add enough timing in there as I thought I did. Pause. So even pre-recorded demos don't go so well for me. So yay for me. I know it. So let's just step through this slowly here. So the 3 main things you need to take a note of here is apt2.py. That is going to be the primary script you're going to run to get it started. Default.cfg is your primary config file. There's going to be, that's where default file paths and any configuration stuff goes, of course, the config file. And all modules are going to be located on the modules directory. You'll see demo.xml. That's just an NMAP XML file that I'm using for this demo. And the rest of it is your standard README and things of that nature. So let's get moving through here. All right. So yeah, demo XML. So first thing you're going to do is, what did I do? Oh yeah, you're going to run it with the -H. You have your standard options here. You have your verbosity, you have your bypass menu. That's to account for a menu that we're adding into it that you don't always want, so your -B would bypass it completely. And -F to provide an input file, which I will do because I have demo.xml on there. So let's go ahead and, oh, we're looking at the config file. I guess I just made this yesterday and I forgot it already. Man, my memory's getting bad in old age. So you'll see there's Metasploit, user password, things of that nature in there. There was a threading, a number of threads you're going to run. For this demo, I am going to use Metasploit, so I'm kicking up a MSF console. I'm going to set it up to use MSG-RPC, setting it with the username password that I had specified previously. Now over in the actual APT, it will know to make use of that. Look at the output again. So we're going to run -VV, which is very verbose, B to bypass the menu. Set the safety level to 1 because I live dangerously, sure. And I'm going to use my demo.xml file. This is on a home hacking network I have set up. And things start scrolling by pretty quick. Let me move that mouse out there so you're not seeing that there. So yeah, it loaded 33 modules and stuff is just scrolling. And as I said before, that's hard to see right there, but let me pause it. Anytime a module can't run because it has the tool it needs isn't there or something of that, it'll show up at the top up here, such as module responder is disabled, dependencies required responder, and I just added in disabled because I'm still working on it. You can disable modules easily that way. So there's any number, if a module can't be run, it'll show up here, so it's easy for you to find the ones that you need to install or update, things of that nature. So let's go ahead and keep going. Okay. It loads up the NMAP file, it parses it, and anything in red down through here is typically going to be a vulnerability or some major finding you want to look at. It found SMB security mode not being required, a bunch of output down through here. All of this is verbose and debug information. You don't need all this on the screen at all the time. It's just one of those things that for this demo I'm showing it. It's running git host, and right there it found anonymous FTP. What is that one? Null session. Here in a second it will find MSO8067, a bunch of other little findings in there. Oh, there it found the work group, which was work group in that case, but there are other ones in there. So it's all these things that you're going to be doing by hand, but it's doing it and adding it to a knowledge base. Right here is an interesting little thing too. It found that one was part of HackNet, so that's what I was showing. And the current number of active threads, I set it to 10 for this demo. So at any given, as it cycles through there every few seconds, it will tell you how many active threads there are and which modules are currently running, so you know if it's stuck on a particular one or something of that nature. There you go, MSO867 was found on 10.10.1.133. VNC Brute was found, that system was found vulnerable to MSF, or VNC Brute. Scrolling down through here, lots of other stuff. Like I said, this is the very verbose output, so lots of output in there. You don't need all this. Was able to pull a user list off of a Linux system. There's another one down here that it pulls off of a Windows system. There you go. Pulled users off of a Windows system because of null sessions. Keeps going on down through there. Yeah, administrator, test, admin, AC. So interesting looking accounts there. Let's see, what else do we find here that's interesting? It's a good one here somewhere. You can see it's doing Hydra SMB password checks. It's doing, yeah, right there. Anything good? Good. Well, I think it's going to jump down here to the bottom here in a second. MSL 8067 is checking. It's running secrets dump. IAM packet's secret stump because it was able to actually log into a system at this point. Because it found a test account with password of password, logged in with that user, was able to dump secrets using the secret stump command to dump that off. Lots of other little things scrolling down through here. And there is an error, which I just left in there just because this is not a final product at the moment. It's definitely one for you to check out, try, and help make better. And at the end, it finishes, and it does, oh well, it's gone, but it does create a report file. The report file isn't finished yet. That is, Austin is working on that, and this is a very early version of that. So let me just jump back here for just a second. Oh yeah, there you go. Interpreter recapture the session from the MSO 8067 earlier. At this point, you have new files in there, log, proof, and reports directory. Let's go ahead and look in the logs. There is a processlog.txt, which contains time-stamped output of everything that this tool did. As far as what, if you don't even enable very verbose, it still will output into this file. So you can go back and see what was run against what system at what time. So we'll go down a directory. Let's go into reports next, I believe. Yes. There is the reports file. I'm not going to show it because it's still heavily work in progress. The idea is that it will give you a good HTML output that will show you what is going on, what kind of findings were found, nice output. Here's the proofs directory. Like I said, the output of every command is in here. IAM packets, secret stump files there. Let's take a quick look at that. If I can do the star. There you go. You have the hashes out of that. At the moment, I don't have the John the Ripper module working properly, but if it was, it would have captured this, ran John on it, got the output, updated the knowledge base for other tools to continue on. This was an easy one. I'm also going to write one for hashcat if I don't have it in there already. Let's see, what else are we going to look at here? Because honestly, I don't remember. I was high on Sudafed last night because of allergies, so we'll see what I did. And, oh yeah, we're looking at the Hydra output. So the Hydra output. So reason I saved all these files in the proofs directory is also when you're doing your report, I don't know how your companies want you to do the reports, but Rapid7 wants us to do screenshots in there. So if you have this output, you can select it, screenshot it, put it in the report. It's great proof, great visual for the customer to see. And what else we're going to look at? Like I said, everything's in there. Everything from the MSO 8067 output, the sysinfo output from the Metasploit session, it's in there. All the outputs you want are in here, and all these things chain together to get to this point. All these are tools that I typically use on engagements. You've got your anonymous FTP up there, which also has a PCAP associated with it of that interaction. So you can capture that output, you can take a screenshot of that, put it in the report as well. So you can say like, oh yeah, look, you can capture creds over the wire, things of that nature. So what are we looking at here? MSO, oh, the dump hashes, yeah. So it dumped those out with the Metasploit module as well, with Mimikatz, wdigest. I think next we're going to look at the knowledge base. Yes, it is an XML file. Not a well-formed XML file, but it is an XML file, which I probably will tweak and make better later. It contains the location of the output file for any vulnerabilities, things of that nature, what ports, what hosts, what users, ports that are open, other versions that were found, things of that nature. So this is the on-disk version of that knowledge base so that it can reload it later and continue on. And I believe that was it. Yes, that is the end of the demo. So let's jump back over here and see if I can jump back into here without it going back to the beginning, because I'm not a PowerPoint guy. And no, I can't. Let's jump through. Sorry about that. I'm a hillbilly, not a PowerPoint guy. All right. So now we're over to the development of it. It is open source, or should have been by this morning, but I didn't have access to GitHub this morning. So as soon as I get a chance and I get out of here and get back on the internet, This will be a public repo. It's at github.com, Moose Dojo, APT2. Go check it out, download it, try it out. Tell me if it's horrible, if it's something that's reasonable, something you want to work on, something that you have recommendations for me to work on, things of that nature. By this evening, it will be a public repo. Like I said, as soon as I can get to the internet again. Future plans, I want to import from more than just NMAP, whether it's Burp, it's Nexpose, it's Nessus, it's whatever tool out there of your choice. I want to be able to import from that. Even if you're running Saint, and I don't know if anybody who still runs that, but if you're still running that, please, if you want to write the module for that to import from it, great. Just write it up and do a pull request. I want to do more attack chains, such as taking output from responder, which I have started, passing into John, throwing it to Hydra, going into secret stump, blah, blah, all down the path. I'm not sure what I meant by that, but yeah, multiple passes. I don't remember what I meant. Make the reports prettier and other things I have yet to think of. I don't know. There's lots of other things this can do. Right now it's focusing a lot more on the information gathering than on the exploitation. That doesn't mean that's where its focus is going to be. That just means that that's where I've spent the most time so far, because some of those tools were the easiest ones, and those are the ones that's helping me out in engagements. If I can automate a lot of that information gathering stuff, I'm happy with that for right now. I'm going to be working on the other stuff as time goes on. But if you want to focus on some other aspect of it and you want to help develop it, please help out, do whatever you want, and we'll be chatting about it if you want. So, questions, my name, Twitter, corporate email, private email, where you can find the tool at, and questions. I don't know how much time we have. Let me see. Oh yeah, we have plenty of time. I flew through that. Sorry about that. Yes, front row, peanut gallery.
I got a real question. Please.
All right, go ahead.
Is the data stored in an actual database or just XML files?
Is the data actually stored in a real database or XML files? It's stored in an in-memory data structure currently. It's in-memory Python constructed data structure, but it is abstracted from the rest of the code, so I can switch that out with a SQLite database or something like that if I so choose down the road, if the current implementation finds to be faulty or the slow bottleneck portion of it or something like that. But it is completely abstracted, so it just has API interface to it, so I can replace that with whatever I want. Right now it's just it's a funky little data structure construct. It's hard to describe, so.
Also, you said multiple passes. If I repeat the NMAPs, I'll put into once we'll run the same check table.
If you feed the same NMAP file into it multiple times, right now it's going to run through the whole thing twice, because the load knowledge base isn't implemented yet. As soon as the load knowledge base is implemented, it will load the old knowledge base back in. Anything that's already been checked won't be checked again. But like I said, not published final product right now. It's still work in development. But yes, that is the way I intend it to work. Any other questions? And I got light glaring in my eyes, so I can't see if there are hands. Anyone?
So, is it, if you're running it in a more dangerous mode, is it expected to be deterministic? Like, will it run the same way multiple times, or you get locked out one time but not another? And obviously you have a reactive network designed to do that, but in a typical case, is that likely to happen?
If you're running it in like a safe level 1, well, safe level 2, well, let's go. Safe level 5, pure information gathering, shouldn't be anything bad. 4, you're probably checking some default accounts like admin, something like that. Nothing should really happen with that. 3, you're going to start doing a little more aggressive stuff, but still no real brute forcing of locking out accounts, all that. 2 is where you're going to start doing password guessing, dictionary attacks, things of that nature, where you might start locking out accounts. And at the moment, if it locks out an account, it keeps going. Well, once an account is locked out, don't know if this is added in, but once it can determine an account is locked out, it should stop processing that account. But that doesn't mean it isn't going to move right on to the next one and lock it out, then the next one and lock it out. That's where safety levels come in and how certain you are with that. And level 1, good luck. it'll probably crash your network, because there are no modules at level 1 at the moment, but those are the ones that it's like, if you run this, like in Metasploit, think back to that, if you run this, it can give you remote code execution, but if it's done incorrectly, it'll crash your network. That would be a level 1. So be cautious with those. You can run that in your lab environment, things of that nature. And if you find that my logic in this is flawed, please let me know. I'll try to address it in the code. I will ask you to help address it in the code if you're so inclined to help out with it. But at the moment, there is no real cutoff in there saying that, hey, I'm starting to lock out accounts, I need to stop, or something like that. No, it's like, oh, I locked out that account, that's fine. Okay, let's go on to the next one and keep going. So yeah.
One more picturing is like if you had two identical networks that you were analyzing just like independently, and you were doing it at an aggressive level 1 or 2, would you be pretty sure you're going to get the same result, or could you encounter a race condition or something in a module and get different results? Like, is that something that's a goal to try to?
Right. So the question is if you're running, whether it's on multiple networks or the same network multiple times, something like that, running it with the threading, is there a case for a race condition where one module might muck with another module to prevent something from running? There's always going to be a case where if you're running too many threads on a congested network, you're going to have packet loss. So that might interfere some way that way. But just from one module running in another one, there is also the possibility there that if one happened to lock out an account or happened to blue screen a device that the other one hadn't checked yet, yeah, that's obviously going to interfere with that other application or the other module. So, but it should always do it the same way every time. So if you run it one time and that happens, you run it the second time, it should happen in the same sequence again for that particular network with that particular set of findings and IPs and ports and what have you. Did that answer the question, or did I talk around it, or did I just go in left field?
Check, check.
That answers it. My concern was like if there's some like random noise or something where a module takes a little longer than it normally does on one of the networks, will that interfere, or are there checks to make sure they happen in a particular order?
No, there is no check to guarantee that things happen in particular order by design. It is designed to say that whenever an event fires, every module listening for that, well, it won't start immediately, but it goes through the list, say fire, 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 fire for each of those modules, and they will start off running. If something happens to delay one of those during execution, then yes, a different output could happen in that case. But no, there's no logic in there to force them to run in a particular order while waiting for this. The only logic in there to anywhere related to that is to say that this module requires this event to get started, and then it will fire another event. That is the only kind of control structure in there to say what order things should work in. Module's only going to run when its event is fired or popped off the queue, and yeah, that's the only control structure associated with that process. All right. Anything else? Anybody else? Front row again.
There you go.
Microphone.
This is not good.
I forgot what I was going to say, got a mic in my hand.
Oh my goodness.
Can you pause the program while it's still running, and if not, are the threads set up to where you could programmatically pause a scan?
No. You can control C and kill it. But as soon as I get the load knowledge base function cleaned up, you will be able to say rerun it with the same XML file, say load this knowledge base, and it should go back and start back where it left off. It may have to rerun certain modules from the beginning because it died in the middle or something like that, but yeah, that's to be the only way you can pause, is to actually kill it and then restart it sort of close to where you were. So
I was just thinking of how to handle the client calling you and saying, "What are you doing?" And you're like, "Oops, stop."
yeah, so that'll be the way that, well, hopefully the client isn't going to call you and saying, "What are you doing that's taking down my network?" Because in those possible scenarios where that could happen are the ones where you didn't regulate which safety level you're running at. You may be running a little too aggressive, or there's just that odd scenario on that customer. Yes, that customer is very picky about something or what have you. But honestly, the solution there is Control C and then restart it after the fact. So, yes, no? Go take a break? All right, works for me. Thank you all very much. Have a great day.